Let's go to space now. It's soon lunchtime. From space we will look at the forest. And I am myself a forester by training, hardcore you could say. But yeah, I was just thinking now it will be fun for the translators also to do it the opposite way of translating. But I see that you're taking the risk to understand my English. Well, that's very kind. But yeah, I studied forestry 15 years in university full time. That's completely overboard, but sometimes it goes like that. But what's interesting is that my connection with Latvia more closely started from that also because in 2003 I went to Sweden to study forestry together with Aris Janssons, who you all know well, and so I know him for now. That's over 20 years, which is, wow, yeah, well, that's why it's getting gray. But yes, I was a scientist, forest carbon, ecosystems, and then I went to the ministry, and I had the same job than Aris. I was the director of forestry in Estonian ministry, and then somehow I ended up in space industry, and yeah, so forest industry and space industry. Yeah, so now today I represent space industry. This word sounds like a bit, huge, but anyway, there's a lot of people who deal with space, and my company, our company where I work in, is in Tartu. It's called Kappazeta, and yeah, I'm very honored to be here. It's a prestigious conference, and very happy to tell you about remote sensing. I tried to put a fancy name, from pixels to pines. I mean, yeah, like what we see is pixels, but if we see really small pixels, then we can see pines. Yeah, and yeah, I will talk about what remote sensing is. I mean, I guess roughly it's not so hard to imagine. You look from the sky, but for example, right now it's cloudy, and like what a wonderful view you have here. Wow. I mean, it's probably, you get used to it, you don't appreciate, but for me it's not every day, so I'm like, wow, this is really cool. And you can almost see this from space also. And then I will talk about technologies and data sources and what you can do in forestry. And I will then also tell what are the challenges and where is the space going, space solutions for forestry. And this is actually, the picture is AI's vision of looking at the slides and making a picture, and it's quite cool, remote sensing type of art, I would say. But yeah, what is remote sensing? So it's getting data about something without being there, without being in contact. So actually, from here, I mean, you can do remote sensing basically also with your eyes, looking at the distance, looking at Jelgava. But yeah, so you can look very far away from the orbit around the Earth, and everybody, I guess, who studied forestry in here knows aerial photographs. This is very. This is old school. The planes used to fly, and we would look at those pictures, with this 3D type of glasses where you have I don't know what it was, but anyway, it was kind of cool. We've gone a long way from there. LiDAR, you might know LiDAR. LiDAR is light detection and ranging is the name fully, but the planes usually carry those lasers around, and they collect very good data about forest. But it's a bit expensive to fly. And then, of course, satellites. There's a lot of satellites. I'll show you some, but they collect a lot of data. They circle the Earth, and they collect a lot of data. And the data itself is not very interesting or valuable. You have to make it to something that you can understand, and then maybe make decisions or understand something better about your forest, for example. So it's really big work to make this data make it understandable and useful. And here another picture about the ways of how you can measure forest. And again, of course, our new scary friend AI, good artist. I mean, this is also cool. I almost want to print this out at home. Like, we used to, let's see, yeah, no, you know, classical. Everybody, I mean, I think you're forestry people. Like a lot of you had to do that. Go to the forest and measure the trees, touch the trees, touch the soil, and this is great. Like, this is very good. You can learn a lot about forest, but it just takes a lot of time, and there's only like so much places you can go. So you're limited in that. So that's why we have NFI. You know, we can't measure every tree all the time, but we have to take samples, and then you can take drones. Nowadays, drones, like, you know, now it's very, very regular to have drones, and also in forestry to go to the forest and you don't walk around and measure, you fly a drone and drone captures some data. But you still have to go to the forest. And then this is a plane which is potentially carrying this LiDAR sensor or also an optical sensor. But usually these planes are much smaller. They are like not those, like this looks like a passenger plane, but it was too difficult to explain AI to make like a small plane, so I left the big one. And then the satellites here flying, well, there's only one here, but yeah, they are gathering lots of data, including about forestry. So some details. So just, I mean, it's like it's a little bit like a university lecture about introduction to remote sensing in forestry. And I don't know how much you know about it and how much you use, but hopefully you learned something new. And I would, you know, like as coming to this line of work also not very long time ago, I'm surprised of what is possible and what is happening. Yeah, so you have passive sensors and active sensors. Passives, they just gather data, they don't emit anything, and then there are actives that send out signals and then take it back, and then based on that can know what the landscape is, or doing Earth observation. But optical is very clear. You know, it's like a camera taking pictures. Nowadays they are so good that you can see, you know, I mean, everybody has seen Google Earth, but you can see people from orbit. Not the face yet, but they are joking about being able to see faces, which is yeah, where we're heading sooner or later. But of course, clouds, when you have, like now, completely useless. Can't see through the clouds. Just that's it, like no picture. And if you're wondering, you know, how many cloudy days there are many, many cloudy days, and hundreds of days per year could be cloudy. So if you use optical data, there could be a problem because you can't just see. Multispectral, hyperspectral, thermal infrared, and active sensors like LiDAR and radar, synthetic aperture radar, SAR. This is what our company is dealing with a lot also. So the radar can see through the clouds and can see at night, and the data, of course, is not understandable for human eye. Like you can't visually really tell much when you make it like a picture. You have to really use pretty advanced analytics, and then you can see a lot of things about forest. And now just a slide about LiDARs. Yeah, so these are on the plane, and then you can, of course, also with any type of satellite and other data, you can combine them and then use them together to get better insights. But with the LiDAR is the problem of coverage, that you can't fly. For example, in Estonia, we fly 4 years to get the same season, the summer coverage of all the forest. And so, you know, some of the data is 4 years old. In Latvia, I think it's kind of similar, and so it's just not up to date. But in forestry, you know, 4 or 5 years also not always necessary to know. But what is very, I mean, it's a strange problem right now with those LiDAR planes and this data, which, by the way, is utilized a lot. For example, in Estonian state forest, they basically don't need to go to the forest to do basic forest management planning and measuring. It's enough what they get from LiDARs. And this is then a political or a policy situation where the forest law of Estonia says that a man or a woman, actually I don't know how it's written there, like a person has to go to the forest and measure the forest on site, and so that's why state forest has to do it. It's not that they don't know otherwise. They could use LiDAR data, or they do use it anyway. But yeah, so now our evil neighbor, Russia, is jamming the signal of GPS. So basically, you know, half of Estonia, I think, similar here. Or maybe a little bit less, but because the signal is messed up, you don't know where the picture or the information comes from, you can't use it. So actually, it's a really serious problem. But then let's look at the orbit. It's a bit difficult to see the satellites, but when you're into this and have some good equipment, you can see them, I guess, sometimes, somehow. And these are some that are used in forestry. Copernicus is this European satellite ecosystem or system. Sentinel satellites, very valuable, free to use. Super useful. There's many remote sensing companies are using data from them. This is European taxpayer money, and our company, you know, this is the data that we use to make products and also tell things about forest. And then Landsat, this is NASA's one. They have issues right now due to funding, because of the things that happen in US. Then there are the German satellites, Japanese, Chinese, and also an Indian-American joint venture. Interesting, this figure here, that it costs $1.5 billion actually to send this satellite to space, which is, well, that's like, that's proper expensive. And I think this is probably the most expensive one. But Airbus, which is a private company making planes and other things, they also have a satellite section or part, and they recently sent out a private satellite, Pleiades Neo, it's the name, yeah, and this costed also $1 billion. And of course, this technology is very intense. And very useful, because of course nobody would invest this money if you couldn't see the benefit of it. And here is just a graph about how the plan with the new satellites is. Of course, they are in development all the time, and you know, they don't live forever. For example, I mean, they have fuel and they have equipment which after a certain time just stops working. So here we have 2030, and yeah, lots of them coming, lots of them there already. So the sky is full of satellites, but in some way, space is really also very huge. So it's not really like that crowded yet. But as you know, like there's companies who send thousands of satellites to space every year, and lots of countries, of course, are involved. And I guess one thing to mention is that EU is really behind in terms of funding for remote sensing compared to other countries or areas. So you know, yesterday I was at the conference about dual use of satellite data or satellites. Dual use means use for civilian and military purposes, and today this is a new normal part of satellites is to use the data also for military purposes, which, you know, let's say 5 years ago was really in EU was a no-no. Nobody wanted to really talk about it, and when you develop something like this, it was like non-military, but now the situation has unfortunately changed. But here's a picture about pixels. We don't see a pine really here, but yeah, a nice representation of satellite capabilities, like it's some type of area that it collects information, and the development always is smaller and smaller. And like I said, one day seeing human face or getting data about that. So but of course these are the ones that cost money also, and a lot of this very good resolution data is available for in the market. But yeah, now the resolution of regular normal satellites, which are not too expensive, the data is sufficient for forest applications. So obvious things: forest height, you can see. Volume, biomass, carbon, this can be calculated through equations. Disturbances, logging, storm, bark beetle, or whatever happens, you can see. And even biodiversity, like you can see, for example, tree structural diversity. And I guess the goal, for example, for our company and many others who deal with this is to have a full forest inventory where, people don't need to go, well, you always need to go to the forest, but you get more information faster and maybe more details, so it's kind of easier to handle all your forest. And there was a big news recently about Seedre forest sales. So now in Latvian private forestry, you have a new player, very interesting. So they have a lot of forest, and so in these kind of cases, the data is important, and if you can get some valuable data from space, it's very good. Okay, and who can use the services? Of course, owners, managers, carbon project developers. Now there's a lot of these carbon projects, and then you need to know how much carbon there is, how much carbon is coming, hopefully every year. Environmental boards of different countries to see what is happening in the forest. Agencies who collect statistics. In Estonia, we have a project about this. Certification, conservation, insurance, and some others. So there's a lot of potential users for this data. Here is a little schematic about one project about carbon. So you have scalability and timeliness, improving with satellites, but accuracy is higher when you go on site. So somewhere here is like a sweet spot where you get the data you need. You don't get too much, too little, with a reasonable price. Of course, the price is very important, how much you have to invest to get data that you need. And for certification, so I guess it's not really, like, as far as I know, very directly used, but what it could give is a layer of transparency, because you can see something and you can see, okay, this is the data coming from space, so it's something you can have on the table when you want to have a clear vision of some of the aspects. And for example, you can say some forest, look, this is not harvested, and then you can get data when you do planning for when you go to do audits, and for example EUDR, which is pretty tricky part also, but that's more like a supply chain issue. And if you have some ideas, I will be happy to hear. And the challenge is, of course, for understanding anything from space about forest or anything, you need to have training data. You need to know what some type of measurement from space represents in the forest. So this is very important, to have good data to train the models. And then, of course, it is tricky. It takes years to learn forestry. It takes years to learn to handle this data also. And then there's AI modeling involved, and this requires also very high experts who are also needed in many other fields. So last slide, in our company, in Estonia, we are right now, wakey, somebody's morning alarm. But we We are doing for Estonian government clear-cut detection system, which every month gathers all the clear-cut information. So you will see every month where a clear-cut happened. So we did a pilot study about this, and it worked really well. We found 90% of them correctly. And we do agricultural checks. We have a map about clouds, and then we do also defense. Yeah, if you have some ideas about remote sensing, so feel free to talk to me. And last, in some years, we are planning to send to space our own satellites specifically focused on forestry to gather data about forest. Yeah, this is a big forest mission, first Estonian commercial satellite mission. Thank you. Thank you.
Thank you very much. Thank you for your great presentation. It comes from participants of conference, and they have some questions to you. The first question will be about Estonia. Does the legislation in your country support the acquisition of forest inventory data based on the remote sensing data?
Yeah, so like I said, you can use it. And there's not like a problem of using this data, but for example, for regular forest management, where you want to do clear-cut planning or whatever type of harvest planning, you still need to go to the forest. So currently the law says you must go to the forest to measure. And of course, the state forest who also does that, they want to change that because they don't see the need, because what they see from LiDAR and satellite data is the same error level. So basically, the technology is there, but the law still has to catch up. And this would save money, basically. Yeah.
Okay, thanks. Considering the strict air transport rules, are there plans to simplify the communication in regards to the users of these technologies?
Airspace and users. Well, I'm not exactly sure about the question, but to send out the satellite is a big job, of course. And once it's there, I mean, you know, whoever does a country or a union, European Union, or a company, they will then have to handle all the work that goes into the proper planning, and just, there's of course a lot of things you have to think about. But it is possible, and it is very valuable, and basically, especially about the defense, we are in a kind of an arms race with everybody else in the world, because you can get a massive advantage about information when you can see from space.
Yeah, and let's talk about small trees. Could the satellite data be used for counting and measuring growth of forest reproductive material in tree nurseries about small trees?
Yeah, well, let's say right now, basically, no. It's very difficult. Like to see something, you know, small trees like this. I mean, you can see them, but to differentiate them, it's possible with the most high-end satellites, which data is basically, I think today, too expensive for the application. So with like easily accessible data, even with LiDAR data, which is free in most countries, you can't really see much about nurseries yet.
Okay, thanks. Have you heard of any AI systems in development that could combine data from various sensors and data sets to give the most precious information on forests?
Absolutely, yeah. No, that is what we do. That's what many companies do. Basically, there are different satellites and different sensors and different data, and by combining them, you can detect something much better usually than with one sensor. So one simple example is that in Estonia, this clear-cut detection that we're doing, it uses both Sentinel-1 and 2, so it means optical and radar data. And so when we did the tests, we tried one satellite data, the other one, and separately didn't get so good results. When we put them together, it was really good results. And then there are many others. You can join in data flows, and so that makes this modeling very complicated, but this is absolutely where the innovation happens. Put things, write things together, and then suddenly you see something that nobody else saw before, and then that's cool.
Okay, and the last question about Estonia, who is paying for the measurements from space? And maybe you could tell how many does it cost per Estonia per year?
Oh yeah, so the LiDAR from the plane, this is from state budget, and this is free data for anybody. I think it's similar in many countries, but from satellites, so countries like, I think Baltics, we don't have our own satellites right now, so it's not like a government could offer a satellite, but these European Sentinel satellites are also built using our Baltic taxpayer money, and this data is completely free. And really is driving the innovation in the space industry, in the Earth observation industry, more in Earth observation industry, and then there are commercial satellites which then every user can buy, and you know, in some countries, I guess if you see a very clear value, like you could use state money to buy a certain commercial satellite data when you see very useful. And what our company will do, we will send our satellites, and of course, you know, this is a cost and we need to get the revenue. So then, but maybe we can get an agreement with a country that will want this data and then make it public in some way or another. And the price, of course, I mean, this is important, that the price has to be reasonable. Like, you know, if it's, I don't know, 100 euros per hectare every year, I mean, nobody's going to pay that. So the price has to be right. So today we are in this balance where with very good commercial satellites, you get much more information, but it's too expensive. So you develop to make this basic good data for you reasonably priced. And we are kind of there, but not fully there yet. So I have to work more.
Okay, thank you very much. I guess this conversation will go on some breaks. Be aware.